Zeal Education Society, redefining excellence.
Hello, good morning to everyone and welcome to Basic Electrical Engineering lecture that is on DC network. Myself Dr. Mahadev Unde, Professor in Electrical Engineering, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the statement of the superposition theorem and how to apply the superposition theorem. In this video lecture, we are going to learn two more numericals based on this. So these numericals are planned as shown. So let us start now. Say this numerical number 3 and say this is 4. Now it is asked to find current flowing through AB, that is 5 ohm resistance, using superposition theorem. Now here we have considered the resistances 2, 3, 4, then this 5 and the two sources 100 volt and 50 volt. Now we can put some things directly also. The step 1 means here we have to find out current flowing through AB when 100 volt acting alone and short circuit 50 volt. Then second step, when 50 volt acting alone, what is the current flowing through AB and short circuit 100 volt. In third step, take the sum of these two currents and that will be the current flowing through AB using superposition theorem. And you can verify your answer later on also at home. So here it is, step 1, when 100 volt acting alone, when 100 volt acting alone, short circuit 50 volt source, that is put equal to 0. Okay, let us put. Now we can assume, see, not necessary to write the network again and again. From the same network, we can assume the direction of currents. Say the current I1 flowing is this one and say the I2 is this one. Okay, so here are two loops, two unknowns, and therefore it will be a 2 by 2 matrix R and I. So here it is. Let us write. Okay, so the first element, or we will write the diagonal element as usual first. So R11, sum of all the resistances through which current I1 is flowing. So it is 6. Then the second diagonal element R22, this is 3 plus 5, 8 plus 4, 12. Okay, and I think we have already solved this numerical by using the Kirchhoff's laws. And it will be easier to verify the answers. Okay, then the off diagonal element R12 equal to R21, and here the current flowing is in opposite direction. Sum of all the resistance is common for current I1 and I2, that is 4, and as the I1 is flowing downward and I2 is going upward, it is minus. Okay, so here it is I1, I2. Now see that loop current I1 is entering into negative terminal of the 100 volt battery, so it is plus 100. Now here the second loop, it is entering into 50 volt, but we have short circuited. You have to put 50 volt equal to 0. You have to put 50 volt equal to 0, already mentioned, and find out the current I2 because it is asked to find the current flowing through AB. So using calci, therefore I2 equal to. Now once again, see, I am using the Casio calculator, scientific calculator, FX100 ms, the modes on. Now see, say go on pressing the mode until you are reaching to the equations. So 1, I have pressed 1. How many unknowns? Unknowns are 2. And that is A1, 6, then minus 4, then 100, then minus 4, 12, equal to this C2 is 0, equal 21.42. This is I1, but we need I2, that is 7.14. But let us check it once again. See, A1 6, B1 minus 4, C1 100, then A2 minus 4, B2 12, and C2 0, I1 21.42, I2 7.143 ampere. And see, as the answer is positive, indicates that this is from A to B. The current is flowing from A to B. Now say step 2. When 50 volt acting alone, short circuit 100 volt, that is put equal to 0. Okay, now write down the as usual matrix. So the R matrix will remain same, only the voltage vector will change. So this is I1, I2, 6, minus 4, minus 4, 12, and here it is. See, for the first loop, here it is current I1 is reaching to the negative of the battery first, therefore it is plus 100. But you have to put the 100 volt equal to 0. Okay. Then for the second loop, while going in the direction of current, we reach negative of the battery first, that is 50 volt. So we have to consider plus 50. Okay, and in this way find out I2 once again. So here it is A1 6, B1 minus 4, C1 we have to put 0, then A2 minus 4, B2 12, C2 we have to make it 50. You can use the same data here. So it is I1 is 3.57, I2 is 5.35. But check it once again. A1 6, B1 minus 4, C1 0, A2 minus 4, B2 12, C2 50 equal to I1 3.57, I2 5.357 ampere. As the answer is positive, indicate that current is flowing from A to B. See, we have assumed the I2 is flowing from A to B. Observe the direction. Therefore, step 3. When both sources acting simultaneously, so current through AB equal to, that is the sum of all these two currents. That is, when 100 volt acting alone, the current is 7.143, plus when 50 volt acting alone, the current is 5.357, and here it is, we have to come out of the mode. See here, we have used the equation mode. Now come to the usual digit mode. So it is 7.143 plus 5.357 equal to 12.5 ampere. And I think this was the answer. Say, when we have solved the same numerical by using the Kirchhoff's law, by using loop analysis, this is also, as the answer is positive, this current is flowing from A to B. This is your final answer. Okay. So I hope you understood it. There would be no difficulty. Now see the solution for the one more problem. Say, what is the question? Find the current flowing through 6 ohm resistance using Kirchhoff's laws and verify by using ST, that is superposition theorem. So first we have to go for the Kirchhoff's laws. Let us put the, how many unknowns are here? two unknowns. So say this current is I1 and say this current is I2. Okay, now put the matrix, this 2 by 2 matrix. Okay, so what is it? Say for the first loop, the sum of all the currents which are flowing, or sum of all the resistances through which current I1 is flowing, that is 5 plus 2, 7. Then see, complete the diagonal element R2, 2. Sum of all the resistances through which current I2 is flowing. So I2 is flowing through 3, 6 and 2. 3 plus 6, 9 plus 2, 11. Okay. Now see the off diagonal element R1, 2, that is equal to R2, 1. Sum of all the resistances which are common for current I1 and I2. Which resistance is common for I1 and I2? 2 ohm resistance. 2 ohm resistance. I1 is going downward whereas I2 is going upward. So it is minus 2, minus 2. I1, I2. And see here, pay attention. While traversing the first loop, I1 is entering into positive terminal of the battery first for the 6 volt source. So here it is minus 6. Okay. Then let us continue. And the same current I1 is entering into negative terminal of the 16 volt battery first. Therefore this 16 volt will be considered positive. And say this is equal to 10. Okay. Then for the second loop, see I2 is entering into negative terminal of the 6 volt battery first, and therefore we have to consider this as a positive. So by Kirchhoff's law, we have to find out the current flowing through 6 ohm resistance, that is the AB. So we have to find out I2. Okay. So once again use calci, use the equation mode 1, press equation 1. How many unknowns? 2. Then A1 7 equal to B1 minus 2 equal to 10, C1 is 10, then A2 minus 2, B2 11, then C2 6 equal to 1.671 and 0.849. So I will check it once again. A1 7, B1 minus 2, C1 10, A2 minus 2, B2 11, then C2 6. So I1, I2 is 0.849 ampere. This is your answer. Okay, this is the current flowing through 6 ohm resistance. Now we have to solve by superposition theorem. And verify the answer. We have to verify the answer. So what is the step 1? When 16 volt acting alone, short circuit 6 volt, that is put equal to 0. So what will happen? The resistance element will remain same, that is 7 minus 2 11 I1 I2. See this equation. See here it is, we have to put 6 equal to 0. So what is the remainder here? 16. Okay, and put here 6 equal to 0. So here it is 0. If you put 6 equal to 0, what is the remainder? 16. So 16 as it is. And find now I2. See A1 7, then minus 2, then 16, then minus 2, 11, then 0 equal to 2.41, I2 is 0.438. Let us check it once again. 7, minus 2, 16, minus 2, 11, 0, I1, I2. 0.438 ampere. and this is from, as answer is positive, from A to B. This is from A to B. Now use the step 2. Use the step 2. What is step 2? When 6 volt acting alone, put 16 volt equal to 0. So resistance element only there will be change in voltage factor. Okay, 7 minus 2 minus 2 11 I1 I2. Now see here we have to put 16 volt equal to 0. So what is the remainder? Minus 6, and here it is plus 6. Find out I2. Find out I2. See, on the calci already we have so many things. A1 7 minus 2, then this should be minus 6 equal to, then A2 minus 2 11, and this should be 6. So I1 is minus 0.739 and I2 is 0.410 or 0.411. Let's check it once again. 7 minus 2 minus 6 minus 2 11 6 equal to I1 I2. I2 is 0.411 ampere. See, answer is positive, indicates that this is also from A to B. When both the currents are in the same direction, that is positive, simply take an addition. If one of the answer is negative, you take usual addition, subtract the smaller value from higher and give the sign of higher value, larger value. Now what is the step 3? Step 3. When both sources acting simultaneously. Acting simultaneously. Okay, so therefore current through AB, that is 6 ohm, is, what is it? Due to 16 volt battery, that is 0.438, plus due to 6 volt acting alone 0.411, and this is equal to, see, 8 plus 1 9, then this is 4 and 448 ampere. As answer is positive, indicates that it is also flowing from A to B. So this is final answer. So in this way we have verified the answer by using the superposition theorem. The same solution we have obtained by the Kirchhoff's laws. So in this way the network solution becomes easy. So I hope there will be no difficulty. Thank you. I will stop here. Thank you. Thank you very much.